Okay, we're going to start chapter 4, section 1. We're going to talk about congruent figures. And you can see that, let's look at the first one, let's look at the homework quiz. I went ahead and did these for you because of time, but I want you to note that x and 55 are supplementary, so that means the x value is 125. But x and y here are alternate interior angles, which makes them equal, so therefore y is also 125 degrees. Same thing for the ones in blue. These two angles are also alternate interior angles, which makes them equal, which gives you an x value of 70 when you solve it. And then for this third one right here, you got y and 114. They're corresponding angles, so that means that they're congruent to each other. So that means that y has a value of 114. And then these two angles right here are supplementary. So x plus 12 plus y equals 180, which gives you an x value of 54 when you solve it. Okay, now with this one right here, you will see that I took the 54 and I moved it up here. Since these two angles are corresponding angles, they're going to be equal to each other, which will make these two angles supplementary to one another. So I just use a supplement. That's why I shaded this angle or highlighted it in yellow, and that's also going to be in yellow, so x equals 63. All right. Now, the objective. Today you'll be able to determine specific congruences and use that information to compute any variable value given the information. Okay, now, here's what you need to know, and I'm going to highlight this for you. Congruent polygons have exactly the same shape and size. If two polygons are congruent, then the corresponding angles and sides are congruent. So, for example, it says here that triangle ABC is congruent to triangle RST. Now, I'm going to go ahead and fill out, I'm going to call this A, I'm going to call this B, and I'll call this C. This will be R, this will be S, and this will be T. So here's what it's saying. It's saying that AB is congruent to RS. I put one slash to it to show that those two sides are congruent. BC, I'm putting two slashes through those, and ST are congruent. So they have two slashes. And then AC and RT are going to be congruent to one another because they have three dashes through them. All right. Now we can also do the same thing with the angles here. Now if you look at the angles, A and R both have one little curve in it. That shows you that those two angles are congruent. Same thing with B, but this time B is going to have two curves, along with S, and then C and T will both have three. See, the reason we do this is we show that A and R are congruent, but they're not congruent with any of the other angles in their diagram. Because if I put just one curve here, that would show that A and B would be congruent, and we don't want to do that because we don't know. All we know is that A is congruent to R, B is congruent to S, and C is congruent to T. That's all we know. All right, now, the big thing I want you to get out of this is right here is the congruent statement. I highlighted it up here, but I'm also highlighting it down here. That's called a congruent statement. That tells you everything you need to know. A is first, R is first. Therefore, angle A is congruent to angle R. B is second, S is second. So therefore, angle B is congruent to angle S. C is third, and T is third. So therefore, C is congruent to T. So there you go. All right. And we'll talk more about that in the next few and as the lesson progresses. All right. Now, it says congruent polygons have the same shape and size. If two polygons are congruent, then the corresponding angles and corresponding sides are congruent. And we just talked about that a moment ago on the previous slide. All right. Now, let's look at the following. Name the following congruences in the given triangles. Okay, so here's what we need to know. And I'm going to do some highlighting here. A is congruent to H. Okay. Now you'll notice that they flipped the triangles a little bit so that they don't look identical. See over here, these look identical because they're not tilted in any way. But if you look at this one right here, they've done that on purpose. So A is congruent to H. B is congruent to J. They both have one curve, but also I want you to show right here in the congruent statement. A and H are both first, so therefore they are in the same spot. That tells you that those two vertices match. That means that those angles are congruent. Same thing with B and J. And then we also have C and K. All right, so with that being said, we also have our three sides, AB, and HJ. BC and JK. AC and HK. So, 1 dash tells you that those two sides are congruent. 2 dashes tells you those two sides are congruent. 3 dashes tells you those two sides are congruent. But also look, AB, first, second, HJ, and HJ, first, second. BC, second, third, JK, second, third. And then finally, AC, CA is second, third, or sorry, first and last. So the positioning in the congruent statement tells you so much. It tells you which angles are congruent. It also tells you which sides are congruent by the position of where they are in the congruent statement. So technically, you don't even need a diagram to show you what's congruent. As long as you look at the congruent statement, then you're good to go. All right. Now, let's look at this particular example. We see that, I'm checking my time, we're doing good. Okay. Triangle ABC is congruent to triangle HJK. So the same diagram as before. Now, let's look at the following. Here's what we know. We know that the measure of angle K equals 3A plus 4. That is this one right here. Well, I look for the other one that has 3 curves, and that is going to be angle C. But also, you know that in the congruent statement, they're both last. So therefore, I'm going to set those two equal to each other. So I have 3A plus 4 equals 48, which when you do that, you get 3A equals 44, which A ends up being 14 and 2/3. It's some funky answer. And yes, from time to time, you will get funky answers, but that happens. All right. Now, angle J, one curve. Angle B, one curve. I have that information right there. Plus, if you look, B is second, J is second in the congruent statement. So there you go. So now I solve. 3x minus 1 equals 104. So 3x equals 105. So x equals 35. All right. Now, the last thing I'm going to go over right here on this particular problem is as follows, which is right here and right there. KH, three dashes, AC, 3 dashes. And you can also see here, AC, first third, HK, first third. So now I have 2y minus 3, and I want to do that in a dark color so you see 2y equals 24. And so 2y equals 27, so y equals 13 and 1/2. All right. Now the next 3 sides are basically what I just did, but I'll just leave it at that. Okay, now. But remember, the congruent statement is so important. It tells you what is congruent. It tells you which angles are congruent. The first angles are congruent. The second angles are congruent. And the third angles are congruent. It also tells you which segments are congruent as well. So you really, like I said earlier, you don't need a diagram, but It's always good to have one. All right. Now, theorem 4.1, the third angles theorem. The third angles theorem says that if two angles of one triangle are congruent to two angles of a second triangle, then the third angles are going to be congruent. So that means if angle A is congruent to angle D, which I'm going to highlight in yellow, if B is congruent to E, then angle C has to be congruent to angle F. Now we could prove that. All we have to do is we know that the sum of the interior angles is 180. We're not going to do that right now. Just know that if you have two pairs of congruent angles, then the third angles also have to be congruent to one another. All right. Now, I'm going to pause this for just a second. All right. We're going to get back to proofs again. Here's what we're trying to prove. We're going to be trying to prove that triangle ADC, which is this triangle right here, is congruent to triangle. I'm going to highlight this in yellow, and I'm going to highlight this in blue. Okay. You'll be seeing me do this a lot throughout this chapter, so get used to it. There's a lot of proofs in chapter 4, but it has to do with triangles. So, all right. Now we know that AD is congruent to AB. We're given that. I'm going to mark it on here. AD is congruent to AB. We're also given that CD is congruent to CB. We're also given that angle CAD is congruent to angle CAB, which I'm marking right there. CAD, this angle right here, and this angle congruent. I mark everything. I want to mark everything as I go through it. I get a visual. And I'm going to emphasize that in class. Angle ADC is congruent to angle ABC. So ADC, which is this angle right here, and this angle right there. Okay. Given. All right. Now, here's what we know. I want you to look at the yellow triangle and the blue triangle. You will notice that they both share common side AC. So they both share AC, and we know that AC has to be congruent to itself by the reflexive property. So I'm going to mark it with 3 marks to show that it's congruent to itself. All right, so now I have 3 pairs of congruent sides. And I'm going to label this angle 1, and I'm going to label this angle 2. Anytime you have angles like that, go ahead and label them with numbers. That's fine. Just make sure you write it on the diagram when you do it. Now, with those doing on a homework quiz, it'll be different, but if you ever had a paper test or something, you'd want to do that. So I have that angle 1 is congruent to angle 2 by the third angles theorem. All right, so now I have 3 pairs of congruent angles and 3 pairs of congruent sides. So now I have enough information to prove, because I have 6 congruences. Remember, with triangles, you have to have 3 pairs of congruent sides and 3 pairs of congruent angles. So triangle ADC is congruent to triangle ABC by the definition of congruent triangles. All right. We'll continue this in part 2 in just a moment.